Welcome to the video on Sigmoid Neuron Using Python by Society of Artificial Intelligence or SOAI. I am Ritul and these slides are created by my colleague Tushar. Let's move to the next slide. Now, in this we are going to study about plotting sigmoid in two-dimensional. Now, steps of plotting sigmoid neuron are, first of all, we should create text cell. The text cell is easily created in Jupyter, and after that import usual commands like we are here importing import numpy as np and import matplotlib dot pyplot as plt. And the third step is write what functions look like in Python. You can see this function as with parameters x1 and x2 and it depends on the five variables which are w1, w2, b, x1 and x2, and this is what the function return. And we had implemented the same function, that is sigmoid underscore 2d with five parameters x1, x2, w1, w2 and b, which will return this, which is equal to the value of this function. Now consider the example of code given. Here you can see this sigmoid with parameters 1, 0.5. Now you can see this in third cell, sigmoid with three parameters and three values 1, 0.5, 0, which directly calls this function and it will return the value which is this. Now, the another step is plot the function. We use linspace function to plot range of number of points. In the fourth cell, w is equal to 0.9, b is equal to 0.1, x equal to np. If you remember, we had import the file as import numpy as np. That's np here. Dot linspace function which with parameters -10, 10, 100, and here y equal to sigmoid function with three parameters x, w, b, and here plt dot plot x, y. After that, plt dot show function. This show function will plot the graph. You can see this here. This is the graph with x-axis is -10 to +10 here x, and y-axis is equal to sigmoid function with parameters. And after that plt, if you read the sixth statement in linspace function, -10, 10 is the range and 100 is the number of equal spaced points we want in the range. The type function of x and y here is numpy dot array. In last step, we call the sigmoid function so the values are updated in the formula. When we use the numpy array and pass it through the scalar quantity, that is x, w, b, it does Python broadcasting where it is calling sigmoid function for every element in x. When we changes the value of w, it changes value of y axis, and if we change the value of b, the graph shifts toward the right side. So in this slide, we are going to learn about steps to plot 3D graph. In the previous slides, we learned how to plot 2D graph, and here we are going to learn about 3D graphs, how to plot 3D graphs. So write what function looks like in Python. This is the function, and here this function will look like in Python. You can see this here, a function sigmoid underscore 2D with parameters x1, x2, w1, w2 and b, which will return this statement, which is like this function. We import a new setting, that is from mpl underscore toolkits, which is library, import mplot3d. So in this we are importing mplot3d. Okay, consider the code given below for a 3D plot. You can see this x1 and x2. x1 is equal to np.linspace -10, 10, 100. x2 is equal to np.linspace -10, 10, 100. And in the next line, x1, x2 is equal to np.massGrid function with parameters x1, x2. Here the x1 belongs to this and x2 belongs to this, and after that the value will store in two variables which are xx1 and xx2. In the next line, here print x1.shape, x2.shape, xx1.shape, xx2.shape. This is the output of what x1.shape return. Now when we move to the next line, w1 is equal to 0.5, w2 is equal to 0.5 and b is equal to 0. and y is equal to sigmoid underscore 2d function with parameters xx1, xx2, w1, w2, b. Ax is equal to plt dot access function with projection is equal to 3d, which is 3-dimensional. In the next line, ax dot contour 3d with parameters x1, xx2, y, 50, cmap is equal to binary. And in the next line, ax dot set underscore x label with, and in the next line, ax dot set underscore x label function with x1. Similarly, in y and z, we can easily change the color of the plot by changing the color given in the single quotes. By cmap, if we change it from the binary to where it is, it would like this. We can even introduce the angle of viewing the plot by using the function given below in our code. And the function here is this ax.view underscore init function with parameter 30, 270. And when we write fig, it will plot this graph. You can see this is a 3-dimensional graph. Here 30 is the azimuthal angle of viewing the plot and 270 the rotation of the plot itself. Remember, these are just a few codes you change and alter these plots with your using the same. Here we are going to learn about steps to plot plots. The first line says plot the graph, in which this statement w underscore unknown is the variable which stores 0.5 and b underscore unknown variable stores 0.25 and x is equal to np.random function with 25, and this function will multiply by 20 and minus 10. Similarly, y is equal to sigmoid function with parameters x, w underscore unknown, b underscore unknown, and after that plt dot plot function with parameters x, y, star. In this, and after that plt dot show function. You can see this here. It will show in the form of stars and with x-axis and y-axis. The second line tells plot the loss function, in which the function calculate loss with parameters x, y, w underscore s, b underscore s. In this, loss is equal to 0. Initially, loss is equal to 0. X, y function for x, y in zip x, y loop loss plus is equal to y minus sigmoid function with parameters x, w underscore s, b underscore s, and after that this whole function will power of 2, which will return loss. And here w is equal to np dot line space minus 1, 1, 100. B is equal to np dot linspace function with minus 1, 1, 100, and ww, bb is equal to np dot mass grid w, b, and loss is equal to np dot zeros ww dot shape. And when we write ww dot shape, here it will return the values, and it will return the values, that is 100, 100. Now for I in range ww dot shape 0 loop, and there is another nested loop in it which will run from 0 in range ww dot shape 1. Here loss I, j is equal to calculate underscore loss function with parameters x, y, w with I, j, b, I, j. Now fig. Here we are going to plot this graph. You can see this here. Projection is equal to 3D. Plot underscore surface function, which is ww dot bb, loss, cmap equal to radius. And finally ax dot view underscore init function with 30, 180 as values. Now fourth line tells us compute what is the minimum value. Here we are going to compute the minimum value. You can see this ij is equal to np dot argmin function with loss. I is equal to int function np dot floor function ij divided by loss dot shape function. J is equal to int function ij I into loss dot shape of 1. And after that we are printing here print I, j. The value of I is 62 and the value of j is 25. When we move to the fifth statement, we may even zoom the plot by changing the values of x and y to get the better hold of the loss function. These are just the basic ways to plot and compute the loss for a given function. You can do many of such examples on your own and can find out how these codes actually for a better understanding of the further slides. Sigmoid neuron using Python. Contour plot. Definition. Contour plot, sometimes called level plots, are a way to show a three-dimensional surface on a two-dimensional plane. It graphs two predictor variables x and y on the y-axis and a response variable z as contours. These contours are sometimes called z slices or iso-response values. Let's move the steps to plot. The first step is to plot the graph, which is similarly x1 is equal to np.linspace function with values in it as -10, 10, 100 and similarly as x2, and after that masquerade function which will give the value of two variables x1, xx2, and after that we are printing x1.shape, x2.shape, xx1.shape, xx2.shape, which will return this. After that, w1 is equal to 0.5, w2 is equal to 0.5, and b is equal to 0. And y is equal to sigmoid underscore 2d function with parameters xx1, xx2, w1, w2, b. The all parameters receive the value from the above statements. Here, plt.counter f xx1, xx2, y, and finally plt.show function which will finally plot this graph. You can see this here. The second step is we can even change the color by introducing new tool in the command box. Here we are going to import another file as matplotlib.colors. The new code looks like this. You can see this is the same code as previous one, and the line after that is my underscore cmap, which is a variable, and it will store red, violet and blue colors. You can see this here. And after that, when we are trying to plot this function as plt.show function, it will return this. This is how the colors are given in the graph. And when we move to the previous slide, this is the black and white and this is the color slide. You can see the difference clearly, but the values aren't going to change. It will remain same. Here we are going to learn the concept of class using class for sigmoid neuron. Let's understand this. Here is the class which with the name sigmoid neuron, and there are some functions in it, like first of all the constructor function, which is underscore underscore init underscore underscore function with parameter self, and here self dot w is equal to none, self dot b is equal to none. So initially the w and b is equal to none, and when we are going to the next function, which is perceptron function with parameter self comma x, it will return np dot function with parameters x comma self dot y plus self dot b, and the another function and the next function is sigmoid function with parameter self comma x, and it will return 1.0 divided by 1.0 plus np dot exponential of minus x function. And when we move to the next function, which is grad underscore w function with parameter self comma x comma y, here y underscore pred is equal to self dot sigmoid function with parameters as self dot perceptron function with parameter x. It will call the above function, this function, and after that when the value is returned, it will store here, and this function is used here to get return a value which we'll going to use further. Now this function grad underscore b function with parameter self comma x comma y, here y underscore pred is equal to self dot sigmoid function with parameters self dot perceptron x. It will also do the same, like this function uh, is called and it will return the value like in this form, and after that this function will return this value, that is y underscore pred minus y, and the whole multiplied with y underscore pred and the multiplied by 1 minus y underscore pred, and after that there is the one more function which is fit function with parameter self, x, y, epochs is equal to 1, learning underscore rate is equal to 1, initialize is equal to true. This is the complete definition, like initialize w comma b. Here we are going to initialize w comma b. If initialize self dot w is equal to np dot random 1 comma x dot shape of 1 and self dot b is equal to 0. This is where the initialization takes place. And after that, for I in range epochs, dw is equal to 0, db is equal to 0. For x comma y in zip, x comma y, dw plus is equal to self dot grad underscore w with parameters x comma y, and in the next line db plus is equal to self dot grad underscore b with parameters x comma y, and self dot w minus is equal to learning underscore rate into dw, and self dot b minus is equal to learning underscore rate plus db. Let's move to the another slide. So here, this is toy data fit. In this slide is the code. Here, x is equal to np dot s array, Sigmoid Neuron Using Python, toy data fit. Here, x is equal to np dot s array with values, and the value of y is this. Here, sn is equal to sigmoid neuron function, and sn dot fit function with parameters x, y, 1, 0.25, true. And in the next line, you can see for I in range of 10. That is, this is the loop which will iterate over the statements, that is print sn.w, sn.b. You can see this sn, w is this and sn.b is this. And after that, there is another statement which is sn.fit function with parameters x, y, 1, 0.25, 4. And there is another statement which is sn.fit function with parameters x, y, 1, 0.25, false. This is the value of sn.w, sn.b. And let's move to the next slide. Toy data plot 1 out of 2. Let's visualize this plot. We will get many such plots. There are just a few examples. Here, x is equal to np dot s array with values. You can see this in the very first line, and y is equal to these values. And sn is equal to sigmoid neuron function, and sn dot fit function with parameters x, y, 1, 0.25, true. Here, this is the function plot underscore sn function with parameters x, y, sn, ax. And here, if you go through this function, then you may see x1 is equal to np dot linspace function with values minus 10, 10, 100. And similarly, x is equal to same as x1. And xx1, xx2 is equal to np dot mass grade function with parameters x1, x2. Here, this parameter x1 will takes the value this, and x2 is this, and yy is equal to np dot zeros function with parameter xx1 dot shape. So the shape of xx1 which comes in this, and after that the nested loop which is this for j in range x1 dot size, it will store in the value val is which is np dot s array function with two variables with two parameters. Similarly, y I comma j is equal to sn dot sigmoid function with parameter sn dot perceptron val. And I would like to add that this it's belong to the previous slides which we had discussed. After completion of this, it will move to the ax dot counter f xx1, xx2, yy, cmap is equal to my underscore cmap, alpha is equal to 0.6. ax dot scatter function x from, you can see this here, x with this value, c is equal to y, cmap is equal to my underscore cmap. And after that, ax dot plot function, it will plot this graph. You can see this here. The x-axis moved from -10 to +10 and y-axis is from -10 to +10. And this plot is given by this code. Sn.fit function with parameters x, y, 1, 0.5, true with n is equal to 20. plt.figure function with parameters fixed size is equal to 10, n into 5. For I in range of n, print sn.w, sn dot b. Ax is equal to plt dot subplot n, 1, I plus 1 plot underscore sn with parameters x, y, sn, ax, and after that sn dot fit function with parameters x, y, 1, 0.25, false. The learning algorithm formulates many plots and arrives at the final plot, which finally makes sense as given in the below plots. It's more accurate than the plot above. It simply tells that this plot is more accurate than this plot. Sigmoid neuron using Python. This is the loading data. We copy the location of the file to access the data so we can move on it. This is the location of the file so that we can access the data. And the second line is we read the cleaned file from our dataset. Here, data is equal to pd to read underscore cv. This is the inbuilt function and pd is mentioned in the previous slides. Okay, so the csv file is mobile underscore clean.csv file. This is what data is the variable which is used to read this mobile underscore clean.csv file, and this is the statement data.head function. In this, the dataset data.head function, the dataset we have looked this like you can see this columns are phone id, pixel density, screen size, weight, ram, and so on, and the rows you can see this 0, 1, 2, 3, 4, and 5 rows into 88 columns. This is what the data.head function returns. Now we have now all the data of rating as commands in the program. In the current given program, which x is the real value output and y is the binarized output for a given threshold. This is data.shape. It will do the rows, column. There is 3, 4, 1 rows and 88 columns in the CSV file. Here x is equal to data.draw function with rating, x is equal to 1. Here we have x which is equal to 1 and y is equal to data rating dot values, and and when the y is written and when we run this code, it will give this output in this form. Okay, and when we move to this, the threshold is equal to 4.2 data with class is equal to data rating greater than equal to threshold dot type np dot int. Now data with class dot values underscore counts function normalize is equal to true. Here you can see this, the zeroth is 0.533724, and similarly the one is this name class d type float 64. Y underscore binarize is equal to data of class dot values. Why do we need standardization? So first of all, we should know about standardization. This is an important technique that is mostly performed as a pre-processing step before any machine learning models to standardize the range of features of input data sets so they can be plotted on the same graph. We do so by making the range such that their mean is 0 and the standard deviation is 1. We will move now plot and show how standardization works. So plot a non-standardized graph. This is the non-standardized graph. From scalar.preprocessing, import standard scalar. Here we are importing standard scalar from scalar.preprocessing. Here R is the variable which is equal to np.random.random function with a 0, with 100, 1, and after that plt.plot of R, plt.show function which By this graph is formed. Now we introduce the standardization. Here, scalar is equal to standard scalar function. Scalar dot fit function with R. Standard scalar function copy is equal to true, comma with underscore mean is equal to true, comma with underscore comma with underscore std is equal to true. Scalar dot mean array, it will return this, and when we write rt is equal to scalar dot transform function of with r, when we write rt is equal to scalar dot transform function this, and np dot mean function with parameter rt, it will return this value, and after that when we type np dot std function with rt, it will give this. So but we have to plot the graph. So here, as seen previously, we just write tld.plot function with rt as parameter, tlt.show function, which create this graph. As we notice, the standardized graph and the non-standardized graph both appear to be same. But when we see the x-axis, the scaling has been changed to standardize all the points. So, test, train, split. We first need to split the data and then standardize it so it goes as forwarded in the code given below. Here, as this is the another program, so we have to import some files or libraries. Let's start. Import numpy as np. Import matplotlib.pyplot as plt. From mpl underscore toolkits import mpplot3d. From import matplotlib.colors for colors. Import pandas as pd. From scalar.preprocessing import standard scalar, min max scalar. From scalar.model underscore selection import train underscore test underscore split. X train, x test, y train, y test is equal to train underscore test underscore split function with x, y, random underscore state is equal to 0, comma stratify is equal to b underscore binarized. After that, when we going to print x underscore train dot save, x underscore test dot save, it will return as 255, 87 and 86, 87. This value is of x underscore train dot save, and this value is from x underscore test dot save. Now scalar is equal to standard scalar function. X underscore scale underscore train is equal to scalar dot fit underscore transform function with parameter x underscore train. In the second line, x underscore scale underscore test is equal to scalar dot transform function with x underscore test. Here, min max underscore scalar is equal to min max scalar function, and y underscore scale underscore train is equal to min max underscore scalar dot fit underscore transform function with y underscore train dot reshape as -1, 1. Here, np.min function with y underscore scale underscore train as parameter, it will return 0, 0. Y underscore scale underscore test is equal to min max underscore scalar dot transform function with y underscore test dot reshape function with -1, 1. You can see this line. It is scale underscore threshold is equal to list by this statement, and after that when we are going to execute this will return this value. Similarly, y underscore binarized underscore train is equal to what if y underscore scale underscore train is greater than scale underscore threshold, it will return in the binary form. And in the next line it is same as it works, but dot as type function with int dot rebel function, it will perform the execution, and after that we will receive the output as this array function with all the values in it. Let's move to the next slide. Sigmoid neuron using Python. Fitting data. Here, by changing the number of epoch of the program delivers us a better accuracy compared to the less training data set. Sn is equal to sigmoid neuron function, as we know. Sn dot fit function with parameters x underscore scaled underscore train, comma y underscore scaled underscore train, comma epochs is equal to 1000, comma learning underscore data is equal to 0.01. Hope so. This statement is clear to you because we are using this statement from a long time, as from very first slide to the this. And after that, I think this code is very easy to understand because in the previous slides we are using the same. Y underscore pred underscore train is equal to sn dot predict function x underscore scale underscore train. In the next slide, which is very similar to the first above one, like this statement. Y underscore pred underscore binarized underscore train is equal to y underscore pred underscore train greater than scale underscore thread dot s type of int dot rebel function. As I explained in the previous slide, it will return the in the binarized form like 0, 1 as integer type. After that, accuracy underscore train is equal to accuracy underscore score function with y underscore period underscore binarized underscore train, comma y underscore binarized underscore train. Similarly, for accuracy underscore test as well. After that, uh, like we are going to print this by a print function with accuracy underscore train, comma accuracy underscore test. It will give us this value. And you can see this the difference in both the codes are here epoch is equal to 1000 and here epoch is equal to 5000, and you can see this everything is the same, but the difference in value comes out is this. You can see this here accuracy underscore train value comes out 0.76 and so on, and here the value of accuracy underscore train comes out is 0.6 bar. It is the key difference of changes in input. Loss plot. We add the following commands on our command cell of class of sigmoid as stated in above slide. Here, this is the function, fit function with parameters self, comma x, comma y, comma epoch which is equal to 1, comma learning underscore rate is equal to 1, comma initialize which is equal to true, and comma display underscore loss is equal to false. And after that, we are initialize from w, comma b. This is what we studied in the previous slides, but now we may go through it for a better understanding. If initialize self.w is equal to np.random.random function with 1, comma x dot shape of 1, display underscore loss. Here, if this is true, then loss is equal to, you can see this here, loss is equal to, and when we move to the next line, here for I in range of epochs, here epochs is 1, dw which is equal to 0, here dp is equal to 0. This is the initialization phase. After that, for x comma y in zip x comma y, here dw plus is equal to self dot grad underscore w with these parameters x comma y. Self dot w minus is equal to learning underscore rate into dw. Self dot b minus equal to learning underscore rate multiply with db. After this, if display underscore loss is true, then y underscore pred is equal to self dot sigmoid function with parameter as self dot perceptron function with parameter x. And in the next statement, you can see here loss I is equal to mean underscore squared underscore error function with parameters as y underscore pred comma y. And when this is complete, this for loop is iterated, and after that, this is the another statement which is if display underscore loss plt dot plot function with loss dot values function, and the next line plt dot labels function with epochs, plt dot y label as mean squared error, and after that we are going to plot the graph with plt dot show function. So this is the graph. So this is the graph which comes out as the above is the final graph we get after the algorithm uses the data given to plot the graph and show how the loss factor decreases and can be made more accurate by analysis the graph by zooming it and out by changing the value of epoch. As the value of epoch is 1000, 2000 or 5000, it will vary. Now we are going through progress bar. This notebook is used to show your progress of the program as follows. Sn is equal to sigmoid neuron function, and this statement is Sn dot fit function with x underscore scale underscore train, comma y underscore scale underscore train, comma epochs which is equal to here 2000, comma learning underscore rate which is 0.015 here, comma display underscore loss which is true. You can see in this statement, and after that this is the progress bar. It basically shows how much time your program is going to take to run itself and be executed and give an output. So here this is the conclusion. In this slide we have learned the following. So what we learned, the first is how to import data using function.csv. Second, how to standardize data by standard scaling and min, comma max scaling. How to rewrite components according to our need as the program and making changes in the function as and when needed. And the fourth one is logging in and displaying the loss function, although it's just the start and very basic form of computing the loss function, but that's how it proceeds. Fifth is using the notebook function like tqdm, which helps to know the exact time that would be required to execute the code. And sixth one is also a main note to the readers is all the codes that are used in the above slides are interlinked and not separately coded as while practicing it on your own do it all together in a single compiling page. Don't be limited to these slides. Do go online and study the material online too. And what makes a man perfect is practice, so practice as much as you can by changing the data. Thank you.